Hello guys, welcome to you all again in the another session of Skill Edge. Skill Edge is a platform where we see how the student has transformed their career from scratch to a data analyst and to data engineers, right? So these are the profiles students have received from backgrounds like BBA, BCom. Those students also manage to get such profiles with the help of Skill Edge. Skill Edge is a platform where it provides you all the help related to your career, your switch to the right profiles to get to the right packages and subsequently to the right streams, the right skills. Okay. It is a platform where we are focusing on your skills. Okay. Where we are looking for your skills. Just a second, guys. So sorry guys. So this platform helps you to get the right and actual opportunity to have success in your career. Okay. So that was all about your Skill Edge. And guys, today we have a very surprising thing. Okay. And we are going to see how we can knock to the next point. Okay. Knock to the next point and win the battle of deployment. Okay. So we are going to see how to train your model, how to deploy your model, what all files we require to deploy our model, and rest all things on the same point. Okay. So here we go. First, we need to build our model. Okay. So for building your model, we require some points. Okay. Whenever we are starting with any of such problems, okay, any of your machine learning problems, what is the most required part? The most required part is your ML model. Okay. The second most important before moving to the ML model, what we require data. Okay. So today we are going to see how we can deploy a credit card fraud detection model over the server, and which can be accessible and we can utilize that. Okay. We can actually visualize it as well as utilize it. Okay. Let's see this. First, we will launch our Jupyter notebook. Let me share that code and file. Okay. Here we go. So now, what all points we are going to require? Let's see that first. Okay. We need a Python notebook. Okay. We need a Python notebook, a Jupyter file where we are going to train our model. Okay. So in this file, we are going to train our model. Okay. So why we need to deploy? Why we need to deploy a model? Okay. So now your model is just with your Jupyter notebook, right? Okay. Now your model is just in a Jupyter notebook. We want that model to be accessible from anywhere, right? So how to build that? That is your deployment. Okay. Now here we have template folder, your Python notebook, your app.py, your data file, your model name, okay, and the requirement.txt. Okay. Sir, okay, these are the important files, but how to build them and what are they? I need to understand that part, right? What are they? Now, basically, templates are nothing but the templates are nothing but your input and output streams. Okay, from where you will get your inputs. Okay, over your websites, and here you can see we have home and predict page. Okay, let's first move towards your Jupyter notebook. Okay, let's understand that code. So here we are moving with your credit card fraud predictive model. Okay, so this is a predictive weight based model where we are taking the 2,84,807 transactions, out of which 492 are frauds. Okay, big fraud people, right? So now we have our data. Okay, what we are basically doing, we are trying to predict. Okay, how to detect the fraud, guys. So this is a simplest example of classification problem where we are trying to detect who will do the fraud with the bank or the credit card team, right? Let's, before starting to any of these models, okay, you should first have an idea what exactly you want from that data, what exactly you want to do with that data, right? So here you need to understand this part, okay? Your data is consisting of fraud and non-fraud, okay? Out of 2,84,807 transactions, only 492 were frauds, okay? Now we have to understand the ratio of frauds is 0.172, right, percent. More than 99% people are not fraud for sure. Majority of the, even 99% people are not fraud, okay? So in this case, if your model is predicting everyone as non-fraud, still your model is 99% right, okay? So in that case, your accuracy doesn't works, okay? Now moving to next point, you can see over here, first step, what, like whenever you are moving with any of such machine learning, step should be to load all the important packages, right? To load all the important packages. You import your Python, pandas, NumPy, Matplotlib, Seaborn and on. Okay, all those. sklearn for your machine learning, all those data. Okay, then look at your data. So second step, read your data. Whatever data file you have, just move with it and just understand. Read that data. Okay. Once you read that data, try to check the number of rows and number of columns. So number of columns will help you to check the number of features. So how many features we have? 31 features we have. Okay. How many instances we have? 2,84,807 instances we have. Okay. Now take a glimpse of your data. Here you can see time, V1, V2, V3. What are these V1, V2, V3? Those are your features. Okay. And finally we have amount. Okay. And what is this class representing? Class is representing zeros and one. Okay. So 0 means non-fraud, 1 means fraud. Okay. Sir, what this V1, V2? These are your features. Basically, they are representing some of the values, okay, which we are going to see ahead. Now, we already know what are the next step. We will take the descriptive part, remove the missing values, okay. Remove the missing values, null values we will remove from your data, okay. Irrelevant data points we will remove, okay. Try to balance your data. Data is unbalanced for sure, right? 99.864, that 864 number student, okay, people or transactions are non-fraud. Only 492 transactions are fraud, right? So you should understand that it is complete, very much biased and unbalanced data set, right? So how we are going to move ahead with this? You can see over here the distribution. Is it really, like you can see, we cannot actually accept this as well, right? 492 is not in consideration too, right? Okay. So this is basically what I am using. I am using a plotly graph, okay? Plotly graph, where I have the liberty, okay? I have the liberty to take my data points to the subsequent levels, right? And this is how your plotly graph works. Now on the data exploration part, I'm looking at the distribution. So the density of it, how at what grounds we get the fraud part, at what grounds your density disturbs from the base mean. Okay. Then moving towards your transaction amount. Okay. Now here we can see the distribution is quite normal. Okay. For as we are moving beyond certain limit, okay, as we are moving beyond certain limit, your mean is also shifted towards the median is also shifted towards the more on a higher side, okay, for your fraud transactions. Okay, so this you have to analyze with the help of your data. Okay, so these are your fraud transactions, amount of your fraud transactions. So here you can see, so most of your fraud transactions are in range to 25 to 149K, right? So you could imagine the level of data points in that range, right? Then we will check the correlation. Okay, correlation matrix. The reason for checking the correlation matrix or Pearson correlation, in order to identify, okay, which all features are more important, okay, which all features are more important, and how to grab those important features. Okay, so that we have identified now with this dark spots, we can identify that it is highly correlated. Okay, this features, like you can assume V20 is highly correlated with your amount, right? V7 is highly correlated with your amount, right? Similarly, you have to identify V20 is yes, white. What does it represents? Amount is least like least related to your V2 column, V2 feature, right? So this you have to identify with the help of your correlation matrix. Okay. Then we will check the distribution of each class with the various density plots, right? Here we have density for each feature. How is your distribution is being mapped? Okay. For your fraud and non-fraud transactions, right? So here we can see that most of your fraud transactions have a have a high variance and low standard deviation, right? Less standard deviation and high variance, right? But on the fraud non-fraud transactions, high standard deviation and low variation, right? So that can help us to identify, okay, as well as our model to identify the pattern, right? Now we will move towards your test train split and build your classification models. Once we check the importance, okay, so we can see V17 is the most important feature, which is contributing 17% for your model. Then we have 15% contribution from V2 feature, V12 feature. So this is an important feature importance part, okay, which we are going to receive, from the random forest model. Random forest model have importance function, which we can use it, to distribute our feature and understand the importance of it. Okay. Now we are moving towards your confusion matrix. Okay. So with this confusion matrix, you can identify this, right? How many transactions are being classified perfectly, right? Here you can see, if at all we are moving with accuracy, it is not going to help us anyway, right? 99% times it is non-fraud, right? So if at all 100% your model is saying non-fraud, then also your model is 99% right? So in such cases, you can see confusion matrix works the best. Okay. So here you can see, so out of how many fraud were there? 72 plus 30. Okay. Out of 492, 72 were classified perfectly. Okay. 30 were non-fraud yet. Okay. Yet it was calculated as fraud. Okay. 7 were non-fraud yet calculated as fraud, right? So this you have to true positive, false positive and false negative. You have to identify, right? So this will help you to check the type 1 and type 2 error. Okay. Then we will see your ROC AUC curve, which will give you how appropriately you manage to get the predictions. Okay. How appropriately your model is performing. So it's 85, like 0.85 is a very good ratio. We can move ahead with it. Okay. Now moving to our main and primary goal, that is to deploy your code. Okay. To deploy your code. Now, if at all you want to share this model, okay, for the actual banking usage, right? Or to your friend to check, is it working perfectly or not? In that case, you need to share this notebook. Yes, you need to share this notebook. But if at all you wish share this notebook, he will get your code entirely. Yes, sir, he will get my code entirely. In that case, will you be able to save your code, like protect your code? That's not possible. If at all you are sharing your Jupyter notebook, that's not possible. In that case, what we share a binary file. We share a binary file of your model. Okay. So it is like your exe file, right? That we just click and install and we can use it. We use that software. Similarly, we will build our pickle file. We will build our pickle file for utilizing that model, just utilizing that model. Okay, not retrieving the code. Okay, we are not going to provide any code. Okay, हम कोई कोड नहीं दे शेयर कर रहे हैं, हम सिर्फ फाइल शेयर कर रहे हैं यूज करने के लिए. ओके, वी आर शेयरिंग द यूजेबल फाइल. So how to move with it, let's understand, because this is an important part. Okay, so we have two ways. We can import joblib.dump. Okay, joblib is a module for translating your model to a file. Okay, translating your model to a file. So joblib.dump, we are passing your model name CLF. So here you can find out CLF, where we have trained our model, right? Where we have trained our model. Now, now, okay. Now here you can understand and get easily, right? Your model is basically is being installed or being saved in that random underscore forest dot pkl file dot pickle file, right? So what we call it as, we call it as pickle file. Okay, so there are two modules. We can move with joblib or we can move with pickle. Okay, both works the same. Okay, there is no difference between the two modules. It's just the two different modules with same kind of approach. Okay, joblib has one function dump. Okay, what this dump function represents, as we can understand, dump means to deposit. Okay, so it deposits your model. Okay, CLF is your model variable into a file name. Okay, so that file name will be saved on your current working directory. It will be saved on your current working directory. So what is my current working directory? Let's check. os dot get cwd. Right, so username, years, desktop, backup 2, and this is my current working directory, right? Now let's see where this model is being saved. So in this location I will get this file. Okay, now, okay, so now we know we can utilize this file. Now we know we can utilize this file. Perfect. Let's understand the principle now. Okay, let's move to the important points. Okay, so now we know, and this is our Jupyter notebook. We have our random forest file. Okay, along with it we have our .pickle file, right? So this is our model file. You can see 1.63 MB file it is. Okay, now what all these other files are? These 5 files we require to deploy our model. These 5 files are essential for deploying your model. Okay, sir, how to deploy this model? Tell me. Okay, so let's check which all files are required. Okay, so then we have requirements.txt. Let's open that file. First of all, it is an .txt file. Okay, it is a text file. Okay, where you will get all the modules with their versions. Okay, you can see we are using Flask, so we got the version of that Flask. Gunicon, we got the version of that Gunicon. Pandas version greater than 0.19. Matplotlib, its version, right? So these libraries have their versions. Okay, so here we will mention all the libraries which we have used, okay, or which we are going to use for your model deployment. Okay, right? So we have used your Pandas, Matplotlib, whichever modules we have used, right? If at all we are moving at any other modules, we can mention over here. Okay, and we will create your requirements.txt, right? Okay, so why we need them? Because we need to install all those modules, okay, to deploy your code, right? Okay. Next point, we have our pickle model, right? We already know why we need it, okay? Because we don't want to share our code. We just want to utilize that particular model, okay? That's why we have built your model file, okay? Now, templates, okay? So just open this template. Here you can see time, V1, V2. You can remember, right? This all are your inputs. This all are, right? How many features were there? 28, 29, 30 features, right? So 30 features we will provide, okay, to our model. And then we will ask your model to build the prediction. Okay. Okay. Here we will write, right? Here we will write our values. Okay. And then we will click on this blue button. Okay. That is your submit. Okay. Once we click on that submit, then this page will pop up as a result page where you will get your predictions. Is it a fraud or not fraud, right? Okay, sir, got it. But these are the just empty values. Okay, empty values. Is it connected now? No, it is not connected, sir. Sir, how to connect them in that case? How to connect them? We will connect them with the help of your .app file. We will connect them with the help of your .app file. Okay, so just imagine this way. You have your one website, okay, where you will be getting some inputs, okay, and those inputs will be passed to your model, machine learning model, ML model. Finally from that model, you will get an output. Okay, so these are your input. Okay, this is your input file, or else you can take this as your input or input page. Okay, input page from you will get your inputs. You will pass to your machine learning model. From your machine learning model, you will get some output, and that will be represented on your output page. Okay, so we will create this input and output page. Okay, so that we have saved in your templates folder, right? That we have saved in your template folder. Okay, so here you can see inside template folder we have home.html and predict.html, right? Okay, now with the help of your Flask framework, we are going to build your app.py. Okay, a Python file which will connect your model, okay, with your input and output pages. Okay, which will connect your model with input and output pages. Let's see how it goes. So here we can see we are moving with your from Flask. Okay, we can also use your Django. Okay, these are the frameworks which we use to integrate your model with your inputs. Okay, and produce your outputs. Okay, so here we are using your pickle and joblib, which we have used, right? I am calling this app Flask framework as app. Okay, now here you can see I'm routing to this, okay, to home.html. I'm starting with home.html, from where I will be getting this information: time, v1, v2, all those variables I will be receiving, right? Okay, I will be taking all the information from there. Once I have taken all those information, right, all 30 instances, then I will keep them all 30 values in a list. I will keep all those 30 values in a list of predict args. Now, after that, I will convert them into NumPy array. Why I'm converting them into NumPy array? Because NumPy array are faster for computation, right? That's why I will convert them into NumPy array. Post that, I will reshape them into 1 comma minus 1 because I want them in the form of, okay, one column. I want them in the form of one column and all the instances, right? Okay, so that I did. Post that, I will call your model. Post that, I will open your model. Okay, with the help of your open method. Okay, we will open your model in the read binary form. How we are opening it? Read binary form. Okay, once we have read your model, then we will move to your pickle model. Okay, using your pickle file, using your pickle module which we have imported. Okay, we initially we dump it, now we are loading it again. Okay, whatever module we have dumped, right? To take some time, just a second. Whatever model we have dumped here, okay, in random forest model 1, right? We have dumped this, right? This your files nclf, right? Same we are going to reflect in your app.py. Here we are reading that binary file, load. Okay, and we are loading that particular model. Okay, and moving it to the prediction, moving that model to predict what? The arguments which we have received, right? The numpy array which we have created, we will pass that numpy array and we will predict the value. Okay, now your value will be your class. Okay, your model prediction will be your class. It is going to be 0 or 1. Okay, that we are going to represent in your model prediction part. That we are going to represent in your model prediction part, right? Model underscore prediction. Okay, so this is how your app.py file works. Using your Flask framework, we are integrating it. We are integrating your model with the input and output. Okay. Now.